Alright, in this video we will review a few of these of the things that we have learned about the unit circle. We will evaluate all 6 trig functions at special angles. We will evaluate all 6 trig functions given a point on the terminal side of the angle. And we will find reference angles and coterminal angles in radians and degrees. So, a lot of fun to be had starting right now. However, before we do anything else, there are 3 facts that you are supposed to have memorized by now. So this is a pop quiz in your face. See if you can answer these questions without looking at any notes. Thing number 1. What is the sign of pi over 4? Answer out loud now. The answer is 1 over radical 2. If you did not know that, you are behind. You need to memorize this fact. There's only 3 facts that you have to just memorize. That's one of them. Fact number 2. What is the sign of pi over 6? I'll give you a moment. That is 1/2. If you did not know that, you are behind. You should be ashamed right now, but don't bury your head. Learn it, and then you can be proud and hold your head high. Now, the third and final fact is cosine of pi over 6. Can you tell me that? Hopefully you just said radical 3 over 2. Alright, if not, you need to stop the video right now and memorize these. Alright, walk away, ask yourself, come back, see if you were right, do it over and over. You have to know these 3 things. Now, if you know these 3 things, there are 3 more things you can get really quickly. And this is the type of thing that you should, as soon as you get a quiz or a test, write down these 3 facts that you memorized, and then write down the 3 additional facts that you can get off of these immediately. Just write them at the top of your paper or on scrap paper before you start a test or a quiz in this unit. So here are the 3 additional facts that we will write on our scratch paper. The cosine of pi over 4. Alright, you just need to know, well, that's going to be the same thing. So that'll be 1 over radical 2. And then we are going to write down the sine of pi over 3 and the cosine of pi over 3. And hopefully you have learned that these are just going to switch. So this will be our radical 3 over 2, and this will be our 1/2. Okay? But you had to memorize these first, and then you just go, oh, I switch them. So now I have these 6 helpful facts ready to go at any time. Okay? By the way, pi over 4, how many degrees is that? Alright, that is 45 degrees. What about pi over 6? That's 30 degrees. And what about pi over 3? That is 60 degrees. If it helps you to sort of keep in mind that these are sort of opposites, pi over 6 is 30 degrees and pi over 3 is 60 degrees, whatever makes you happy. Okay, anyway, back to business. Let's do problem number 1. Alright, so we are given this point on the terminal side of angle theta, and we're supposed to find all 6 trig functions of theta. So, of course, the initial side is always the positive x-axis, so that's going to be here. Now, the point 8 comma negative 15, this is my x and y, so that's like over 8 and down 15. So that point is going to be like here somewhere, alright? So this is the point 8, negative 15. Okay, so that means the terminal side is like that. which means that we are talking about an angle that's doing this. Okay, so this is theta, is the green angle. Alright, however, what we can do is find the reference angle instead, and we can use that, except for we just need to pay attention to the sign. On the unit circle, cosine is the x value and sine is the y value. Now this point is not on the unit circle because it's way out here at 8 and negative 15. The unit circle is much smaller than that. But as far as the quadrant and whether or not we have a positive or negative, we know that in the fourth quadrant here, x values are positive, so cosine will be positive in the fourth quadrant. And y values are negative. See how it's down. So we know that sine will be negative in this quadrant. So just remember this. As long as you keep that in mind about the positive and the negative, cosine and sine, you can go ahead and use the reference angle instead of worrying about the green angle. Alright, so let's find all the trig values of this reference angle right here. Well, looking at the coordinates, 8 and negative 15, 8 is the x value, so that's my 8 right there. And then I've got the negative 15, so it's going to be down 15. So all I really have to do is find the hypotenuse. And we'll just use the Pythagorean theorem for that. So this hypotenuse is the radius, so I'm going to call it r. So here we go. We're just going to do 8 squared plus negative 15 squared is equal to that radius squared. So that'll be 64 plus 225 is equal to the radius squared. Alright, that is 289 is equal to the radius squared. When you take the square root of both sides, you're going to get 17. Okay, and this is always going to be positive. Alright, the radius is always going to be positive. So there we have it, that's 17. Now, armed with all three of these numbers, we should be able to easily make all three trig functions right now. Not all three, all 6. So let's start with our good old sine, cosine, and tangent. Sine is opposite over hypotenuse. So that will be negative 15 over 17. Cosine is adjacent over hypotenuse. So that'll be 8 over 17. And tangent is opposite over adjacent. So that'll be negative 15 over 8. Okay, now let's do the reciprocal functions. Okay, the reciprocal of sine is called the cosecant. So that's just going to be 17 over negative 15. The reciprocal of cosine is called the secant, and that's going to be 17 over 8. And the reciprocal of tangent is called the cotangent, and that's going to be 8 over negative 15. So there you have it, all 6 trig functions. Alright, let's do the same thing for number 2. Negative 7, negative 2. So that's left 7, down 2. That's going to be over here in the third quadrant somewhere. Okay? So, if this is the point negative 7, negative 2, the reference angle is going to be right here. Now we can use this reference angle as long as we actually use the signs on the sides here. So negative 7, that's going to be this side of the triangle, alright, because that's the x values to the left. And negative 2 is going to be this right here, this side of the triangle, because that's down 2 for your y value. So again, as I'm looking at this reference angle, I am really finding the true value of the functions of the real angle theta, because the only difference is the signs. I'm talking about positive, negative. And as long as I'm actually using the signs of these numbers and not just positive 2 and positive 7, that's going to actually give me the accurate answer. So I can go ahead and do it in confidence. So I will go ahead and say the sine. Oh, wait, we need the hypotenuse. So Pythagorean theorem first. All right, I'm jumping the gun a little bit. Carried away. So we need to find this radius, a squared plus b squared equals c squared. So we are talking about negative 2 squared plus negative 7 squared is equal to the radius squared. That's going to be 4 plus 49 is equal to the radius squared. So that is 53 is equal to the radius squared. Not 53, yeah. And that is looking very non-square rootable. So the radius is going to simply be the square root of 53. So let's get that into the game. All right, for your radius, that's always going to be positive. Square root 53. Now we can go ahead and do all the trig functions. If I leave myself room over here. Okay, so sine of theta from this angle is going to be opposite over hypotenuse. So that's going to be negative 2 over radical 53. The cosine of theta is going to be adjacent over hypotenuse. So negative 7 over radical 53. And the tangent of theta is going to be opposite over adjacent. So negative 2 over negative 7, but a negative divided by a negative is a positive. So that'll just be 2 over 7. All right, and now the reciprocal trig functions. The reciprocal of sine is cosecant. So cosecant, running out of space over here, will be radical 53 over negative 2. I'll put a line. Reciprocal of cosine is secant. So that'll be radical 53 over negative 7. And the reciprocal of tangent is cotangent. So that'll be 7 over 2. So there you have it. All 6 trig functions. Okay, now, how do I evaluate all 6 trig functions of something that has no reference angle? Answer, unit circle, baby. It's all about the unit circle. So let's draw ourselves a little sketch of a unit circle. All right, of course, the main thing about the unit circle is it has a radius of 1. Okay, keep that in mind. So what do I have going on here? 90 degrees. So we're talking about, okay, so here's my unit circle. Then here's going to be my 90 degrees is like this. Here's the initial side. Here's the turn. Whoa, my sketches are horrible today. Okay, here's the terminal side, 90 degrees. Okay. Well, here's the deal. On the unit circle, all right, remember radius is 1, radius is 1. On the unit circle, every point is of the form cosine, comma, sine. All right, maybe I should say cosine theta, comma, sine theta. Okay? But we know the coordinates of this point right here. All right? The coordinates of this point are 0, comma, 1. All right? Because there it is. It's over nothing and it's up 1. So 0, comma, 1. So that tells me that the cosine is 0 and the sine is 1. So we're on a roll. So sine theta is equal to 1, and the cosine of theta is equal to 0. Now the tangent of theta, is always sine over cosine. All right, tangent is sine over cosine. So that would be 1 over 0. But that, my friends, is undefined. Okay, you can't do 1 over 0. You can't divide anything by 0. So undefined. Okay, now the reciprocal trig functions. The reciprocal of sine is cosecant. So let's see, what's the cosecant going to be? Well, the reciprocal of 1 is just 1. It's like taking a 1 and putting a 1 over it, it's still 1. Okay, how about the reciprocal of 0? Well, first of all, the reciprocal of cosine is called secant. Alright, you can't do the reciprocal of 0. Alright, if you take 0 and you put a 1 over it, that's undefined. So that is undefined. Okay, the reciprocal of 0 is undefined. Can't divide by 0. What about the reciprocal of tangent is the cotangent? Okay. Remember that tangent of an angle is the sine divided by the cosine. Alright, if you hold that in your brain, then it's easy to understand that the cotangent of an angle is going to equal the cosine over the sine. Alright, because that's your reciprocal. So that's what we're going to do. We can look back to the original sine and cosine that we had, but this time the cotangent will be cosine over sine. So that'll be 0 over 1. 0 over 1 is just 0. So there you have it, all 6 trig functions. Alright, let's do that one more time for negative pi. Okay, so again, here's my unit circle. Alright, the top half of the unit circle is pi. And of course, if I want to go negative pi, that just means I will go around clockwise. Okay, so if I went like that, I just went negative pi. So I'm talking about I had my initial side and then my terminal side ended up right here. So I've moved negative pi. But any way you slice it, here's where I land. Now, what are the coordinates of that point? The coordinates are negative 1, comma 0. Alright, it's left 1, up nothing. So remember that that tells me the cosine and the sine on the unit circle. So right there, I know that the cosine of theta is going to be negative 1 because that's the x value. I'm sorry, my OCD is happening, and I always do sine first. So sine is the y value, so sine is 0. Now cosine, which is the x value, so that's going to be negative 1. Now tangent, alright, which is one of the reasons I always put sine over cosine, because then it's all set up for me. Tangent is sine over cosine. 0 divided by negative 1 is just 0. Okay, so now the reciprocal trig functions. The reciprocal of sine is cosecant. Okay, you cannot do the reciprocal of 0. Alright, that's like having 1 over 0. That is undefined. Alright, the reciprocal of cosine is the secant function. Alright, the reciprocal of -1 is still -1. And cotangent is the reciprocal of tangent. And once again, that is going to be undefined. Okay, you cannot take the reciprocal of 0. That's like having 1 over 0, undefined. So there you have it, your 6 trig values of this situation. Let's stop this video here. We were at 20 minutes, and that's long enough for one video. Plus, we've been doing all 6 trig values in different ways. But the next video is going to get into sketching and reference angles, which is completely different. I'll see you on the next video.